Hi, and welcome to today's presentation, Innovation and Solutions for Embedded and Edge AI. I'm Barrie Mullins, Director of Technical Product Marketing at Nvidia, and I'll walk you through some of the great use cases that we're seeing in the embedded and edge space, and some of the challenges that customers face when implementing AI. And then I will wrap up with some of the solutions that Nvidia provides to enable developers get to market quickly and where you can get started. Right, let's jump right in. So we have seen huge momentum on Jetson over the last number of years, and particularly in the space of AI. You can see from this slide we have over 700,000 unique developers on our platform and over 3,000 active customers either developing or deploying products with Jetson. Here you can see an array of products for different markets, anything from autonomous mobile robots to manufacturing and inspection, and retail to healthcare. We build a product that meets a lot of the needs for many of these different markets. Now, designing and developing systems like these do not come without their challenges. It sounds really easy. It's something that you and I could do very simply. But it's much more difficult to build an actual system to be able to do this. And these challenges occur in many different products where you're trying to develop and deploy AI. And the first one is the growing diversity and the complexity of the neural networks that are available out there. Many different products use a standard network as a starting point, and as they gather more data, then those networks change, and over time, as the systems are deployed, more and more networks become available, which will allow them to expand the capabilities or add new features, and you need to be able to keep up with that technology change. It's not just about the algorithm or the network you develop today, but it's about the algorithm and network that you're going to develop in the future, or that you're going to need in the future to deliver this capability to customers. And the second item is the full stack acceleration. It's not always about how much inference you can run in a system. It is really about how do you do all the pre-processing, all the sensor fusion, gather all of that data, then pre-process that so it's ready for inference. How fast can you do that inference, which to get the data out, allowing you then to do the analytics and provide insight based on that data. And lastly, there is how do you store that data? Where do you put that data for post-processing, further analysis, future training, and so on. And that's critical, and that's what we call full stack acceleration, end-to-end on the products that will be deployed at the edge. And then lastly is there's managing and deploying all of these products at scale. If you think of a very large environment where you're going to put multiple systems, whether it's a hospital or a factory or a city, you need to be able to communicate to all of those devices. You need to be able to upgrade the algorithms and the capabilities of that system. You need to be able to capture the data for the local environment to be able to manage it, even though that system is doing AI all by itself. And then when you have new algorithms, you want to be able to update those algorithms, or you may have other software features and capabilities you want to update. You need to be able to do that remotely in a very organized and systematic way without bringing down the whole system. I mean, AI algorithms that are deployed today will be updated on a daily, weekly, or monthly basis, depending on the system or the environment they're in and what you're trying to do. And you have to think about how you manage that in the future. It's not like a traditional embedded system where you kind of upload or kind of deploy it once and then do infrequent updates and keep the same feature set. AI is very different because you want many updates, many new feature sets, and adapting to the environment and the features and capabilities that you require. So to address all of these, we've developed a software-defined platform that we call Jetson. And within that platform, there are a number of different modules that we deliver. Now, these modules include the system on a chip, memory, power supplies, I/O connectivity, and all of the other features that you would need to manage the system. And they come in a very small form factor, power efficient size, anything from our Jetson Nano, which you can see here on the left, all the way through our Jetson AGX Xavier that you can see on the right. The performance capabilities go anything from about a half a teraflop all the way to 32 TOPS, using our GPU architecture along with some other engines and capabilities that we build in there to be able to accelerate that full stack. The other thing that you can see here is that they all run the same software. We're able to build these platforms leveraging our GPU architecture and then layer the software down on top of that. And that is critical for anybody that wants to be able to leverage software and scale it across many different products, whether it's within a product family or across multiple different product families, or after you've shipped products out to the field where you want to be able to maintain and update that. I'm going to dive into a little bit more about the software now. So this software that sits on top of Jetson, we call it our Jetpack SDK. And this Jetpack SDK comes with many different features and capabilities, including Linux from Ubuntu. It's a reference design that is then optimized for the application or deployment that your system would use. We also support RTOSes and some of the real-time processors on some of the systems. And then we layer on top of that CUDA, which is really a CUDA acceleration software stack that takes advantage of all of the hardware capabilities on our modules. And the CUDA acceleration software includes dedicated software for deep learning, including our TensorRT tools and engine, and our cuDNN tools and engines that unlock all of that hardware potential with that software stack. We have multimedia capabilities and computer vision capabilities for any of the vision, compression, and pipeline needs that you might have in a system with a lot of sensors and camera sensors and video sensors. And then lastly, we have an accelerated compute stack, including cuBLAS and cuFFT for that high performance math processing that many edge systems require in order to be able to do it real time and reducing latency. And then we have a large ecosystem that I'll talk about at the end that provide a lot of different hardware interfaces, as well as all the software drivers and services to be able to integrate those into the system. With this software stack, we also have a suite of developer tools that allow you to optimize and analyze your code and to really profile what's happening in the system. And if you really want to, get in there and get your hands dirty in manipulating the code to be able to maximize the performance of your application on top of the Jetson platform. We also built on top of the Jetson platform and the Jetpack SDK, other SDKs, including DeepStream, which is for intelligent video analytics, and I'll talk about that a little bit further in a few slides, and Isaac SDK, which is for robotics. With all of this software capability, it allows our customers to then put their specific system software and application needs down on top of it to build a system for that vertical market. And here you can see many different vertical markets, anything from smart city to smart agriculture and healthcare and so on. So now as we jump a little bit deeper, I'll talk a little bit more about one of the features in Jetpack and then DeepStream SDK and Isaac. So earlier I talked about the importance of managing and deploying software at scale, and we have enabled Jetson with cloud-native capabilities. That they include containers and microservices that allow Jetson to easier and faster deploy software. It makes the software development process more agile, as you can run a Docker engine on the Jetson platform and then put your containers down on top of that, and you get to define how that software architecture comes together and what is in or out of certain containers. And then you can manage those containers independent of other containers, and you can push updates when required. And this makes it much more scalable than the traditional embedded development environment, and it makes it very portable within a product or when a product is updated. So you may have something that is updated on a daily basis and always connected to the the network, or maybe you have something that only connects periodically, and you can be assured that it will pull the latest and most appropriate container so that update operates effectively and doesn't do anything to the final system. And that so we'd highly recommend for customers that are doing AI to really learn more about this cloud native capability and to better understand what that means and how it operates for AI, because as I mentioned, an AI algorithm that goes out today needs to learn and adapt for all of those new changes in the environment and the new use cases that it detects, and will need to be updated somewhat frequently depending on the application. And cloud native capabilities and containers and microservices allow you to do that much more efficiently and effectively than other means. So now I'm going to talk a little bit about our Nvidia Metropolis platform. This is a software stack that sits on top of our Jetpack stack and enables a lot of the various different hardware technology across Nvidia. Now you can see the bottom there is many different types of GPUs, including multiple different Jetson modules or the boxes from some of our partners. And that, so we layer on top of that all of the CUDA acceleration software that I talked about earlier, including our TensorRT and our cuDNN and so on. And then the Nvidia Metropolis stack or DeepStream stack sits on top of that with pre-trained models for intelligent video analytics, the DeepStream SDK that allows you to develop and build a pipeline and incorporate those models onto the hardware platform. It gives you a transfer learning toolkit that allows you to develop models quickly, change those models based on your data, and then to be able to deploy those very quickly onto the hardware. And lastly, you have the video encode and decode capabilities for anything that you're doing with video sensors. And all of this comes together in a very efficient, effective way because it is optimized to take advantage of the CUDA accelerated software and the CUDA stack, which then takes advantage of the various different capabilities in each of the Jetson platforms. So if you're looking to do something in intelligent video analytics, the Metropolis platform and DeepStream SDK are a great place to start and get you to market quickly. Now I'm going to talk a little bit more about some of the things that you get within that package. So one of the things I mentioned was Transfer Learning Toolkit. This is a high-level SDK for tuning your models for deployment or for inference at the edge. It's a faster and efficient way of deep learning because you start with pre-trained models and you can then apply your data, which has been labeled and annotated, to that model. The tool, the Transfer Learning Toolkit, will then optimize the model based on your data for your application and give you a new model output. And this model output is already set and that for GPU deployment, and all you now need to do is optimize it for the underlying hardware in order to be able to do inference at the fastest and best possible rates. Now, to go with our Transfer Learning Toolkit, we have some purpose-built pre-trained models that you can take. These are highly accurate, and you could deploy them out of the box, or you can retrain them with your data that you have today in order to optimize for a model that you want to deploy. If you deploy them out of the box, you can then gather your own data and then start optimizing the algorithms over time for your application. And with cloud native capabilities, as you gather the data, train new models, you then get to deploy them easily and effectively. You can see these are highly accurate. For the different markets, there's an extremely large data set that they've been trained on, and we provide a number of different classes in each of the different areas. For more of this, you can get them on our NGC or Nvidia GPU Cloud, and I highly recommend that you start here looking at these models and then adapt these models, because the most efficient way to develop an algorithm or a DNN for your application, and then combining that with our Metropolis and DeepStream SDKs, you can easily deploy them on Jetson. And speaking of deployment on Jetson, generally you have to optimize that model for the target hardware, and we provide a tool called TensorRT that's part of the Jetpack SDK and the DeepStream SDKs, so that all of the frameworks and models that you develop or run or use can be optimized through our TensorRT tool for the underlying or target hardware. TensorRT is what takes the DNN, applies a CUDA acceleration software to it, and then runs it on the correct hardware or engine, or the most appropriate hardware or engine within the platform that you're targeting. So if you're using Nano, it will optimize the code for Nano. If you're using Xavier NX, it will optimize the code for Xavier NX and potentially take advantage of the different capabilities that come in those two platforms. So once you get through your learning and you've got a model, you then want to optimize it, and that's what TensorRT does. It really optimizes for inference at the edge in a very efficient and effective way. And it's combined with all of our tools in our software stack with full awareness of the underlying hardware. And that's critical for ease of deployment and scalability of your software and your algorithms across those products and those platforms. If you remember earlier, I also showed you an SDK called Isaac. That platform is specifically designed for robotics. Again, it runs on our unified architecture of hardware, all of the Jetson platforms and our other GPUs from Nvidia. It comes with that software acceleration stack of TensorRT, cuDNN, and CUDA accelerated software, and it builds on that. And the development software that you get for the Isaac SDK allows you to program using computational graphs and messaging. It provides visualization tools that are very specific to the robotic environment or robotics development. And then it's got Python APIs and bridges to ROS and ROS2. And then on top of all of that, we apply accelerated software libraries that are libraries that we've developed that take advantage of the GPU capabilities and integrate into a robotic system because they're critical to certain parts of that. And I'll talk a little bit more about those on the next slide. Lastly, we have our Isaac Sim environment, which is a full environment that allows you to do domain randomization and to do hardware simulation in a software environment, and also include that hardware in the loop where you're generating objects that the simulated environment creates that is seen or perceived by the robot, and then it has to take action and behave like that. And the reason we have this environment, and it's critical for robotics, is that you're never going to be able to create all of the scenarios in the real world to test your robot. So a lot of what you have to train on, or that the robot has to be tested against, has to happen from a software or simulation environment. We can do all of that with Isaac Sim, and then we can do hardware in the loop to test that the hardware behaves and takes the appropriate actions that we expect, and then you can deploy that hardware to the field. So a great platform on which to build robots, and it gives you all of the pieces that layer on top of that Jetpack software stack for inference and deployment of edge AI systems. Now, here are a number of those GPU accelerated algorithms, or GEMs as we call them, that are specific to robotics. They come as part of the Isaac platform. And they include anything from free space segmentation to 3D object pose to stereo visualization. Multi-LiDAR support is part of that. And then we have navigation with the path planning. We support multiple different sensors, and we build our own robot platforms and test all of this in-house. And there's the ability for you to have confidence that these things are all designed, built, and tested in a real robotics environment. We simulate all of these in our simulator. We do hardware in the loop testing, and then we also deploy them around our buildings. Now, to help customers and developers with this, we have built out a very large ecosystem. You can see a number of different companies here that are part of that. We divide the ecosystem down into a number of different areas, specifically around cameras and sensors, because we see a huge demand and need for people to be able to gather their external data and integrate it into the system. And then we have our hardware and design services partners that help you to build out your platforms, potentially design some of the carrier boards, or actually ODM products for you that you can then accelerate that whole design development process from a hardware perspective and a sensor perspective. We layer on top of that our software partners that are anything from independent software vendors with IP that will accelerate AI to embedded software developers that can support you with design services or acceleration or real time of other parts of the system. And lastly, then we have our distribution network by which you can actually obtain all of our modules or our partners' systems if that's what you're looking for. We've also developed a very large Jetson community with a lot of open source code that's available out there. Many people have bought our developer kits and jumped on and just started working on them. We publish all of our material where possible to be open source. And leveraging that open source, many other people in the Jetson community have done the same. And here you can see some great examples of what the community has actually developed themselves. This reading eye for the blind is a great example of somebody who is solving a problem that they have locally, or that challenge that they have from within their own community and their own friends. You also see a weed removal robot that was just built by the community as an example. And we've actually seen full commercial products that are built taking advantage of the same technology, using similar algorithms or more advanced algorithms and that. So if you're getting started today, you can look at this community, see what's available. You can learn from what they've done and then leverage some of the code and learning that's out there to be able to get to the next level. And if you do want to get started today, then we enable that through our Jetson developer kit, starting at anything as low as $99 with our Jetson Nano, and all the way through to our Jetson AGX Xavier developer kits. We have provided a number of different demos and courses that are available out there. We have an online demo that you can build in 2 days. It takes you through all of the steps to be able to develop, train, build, deploy an AI system on any of our Jetson platforms. And with our Deep Learning Institute, we have a number of different trainings out there that are designed for Nano and for DeepStream that you can leverage in order to understand the technologies that are there and also the software stacks that they run. And lastly, for anybody that wants to learn and grow and experience what's happening in this space, I highly recommend that you attend our upcoming GTC. They're held on a regular basis, and they talk about and they inform everybody pretty much on where the industry is going and what's happening from an artificial intelligence perspective and many different other capabilities that we provide and our customers and partners are providing to the world. So lastly, I'd like to thank you for your time today. I hope this was useful and beneficial and that you learned something. I encourage you to go out and check out our website at nvidia.com to learn more about our autonomous machines and our Jetson embedded and Edge AI products, as well as all of the software stacks that we run on top of them. And I look forward to hearing or seeing from you in the future and learning all about what you've created with Jetson. Thank you.